So today we're going to be looking at the Fab Four bookmark, and today's model text that we're going to use is a math text. This is the Fab Four bookmark. We're going to use it to guide us through our reading. We're going to use it before we read, while we read, and then after we are done reading. And as we are doing this, we're basically going to do four things. The first one is we're going to predict. We're going to predict by using clues from the text or illustrations to predict what will happen next. Some thoughts that we might hear are things like, I think, I'll bet this is going to happen, or I bet because, I suppose, I think I will learn. The next one we're going to do is questioning. We're going to ask questions as we read. Some are answered in the book, others are inferred, some may not be answered. Things like, I wonder, or who did that? What is that? When did this happen? Where? Why? Or how? Or even why did the author think that? Or why do I think that? The next thing we're going to be looking at is clarifying. When we get to a tricky part or hard part in the reading, we're going to mark it, and we're going to be looking at mark it so we can go back to it and reread, read on, sound words out, talk to a friend, and get help. We want to clarify our text. The last thing we're going to do is we're going to summarize using our own words. We're going to tell what the main idea is in order by using phrases like these. This sheet is called the Basic Comprehension Chart. This is a sheet where we can track our thoughts as we read. As we get better at reading complex texts, we may just make our annotations on the text itself or in our brain. And just to be clear, annotation means to mark or write a note. In fact, let's make an annotation right now on our comprehension chart. Where it says our predictions, I want you to draw this icon. Predicting is kind of like we're making a prediction with the crystal ball. So the bottom hand is holding the crystal ball and the top hand is waving over the crystal ball, making a prediction. So anytime we see this in our text, we know we made a prediction. For questions, we'll keep it simple. We'll just make a question mark. When we get to the clarification from our bookmark, we're just going to copy the icon from the bookmark, which is a magnifying glass. And then for our summary, we'll just draw a box and put two little squiggles in it for writing a summary. So let's try this out. So in general, my layout, I usually have my reading on my left, and my bookmark and my comprehension chart on my right, just because that's how I do it. Doesn't really matter. We're going to start off by before we read. We're going to do our before we read portion. So we're going to do some prediction. So we're going to use some clues from the text to help us make some predictions. So the very first thing I always look at is the title. So rate of change and slope. So I actually am going to make the little prediction symbol here, saying that I'm going to predict that this reading is about reading our rate of change and slope. So we can even write this. What is our prediction? Article is about rate of change and slope. Now, as you get more proficient at this, you may not have to write all this down because some of this is very basic. But if it's something that maybe you want to remember, you might want to track it on your comprehension chart. Next thing I notice right off the bat is, and as a prediction, I guess I really need to make a prediction here. The prediction I see is something's going to change. And slope, well, I know there's mountain slopes. It's kind of like a hill, so that's kind of what I'm thinking we're going to talk about. Then the next thing I look at is I see then, now, and why. So I'm going to predict that my prediction is that we're going to talk about the past, present, and why things change, maybe, because we're talking about change. Next thing I notice right off the bat are the ones and twos. So maybe those are related to each other. And I see rate of change again. I'm predicting that rate of change must be important. Must be important. And then I see rate of change again down here with this real world example. So it's kind of confirming my suspicions. The next thing I notice is I see a graph, and I see a table, and then I see a graph. So that tells me we're going to be looking at how things change over time, because I see time and temperature. Notice as I'm going faster, and I'm not necessarily writing them down, but I am making the symbol that I made a prediction there. Next thing I notice is there's this stuff over here on the side, and a lot of this looks complicated, and it's like, okay, whatever. And then I see the new vocabulary. Rate of change is slow. Well, I think I know what those words actually mean, but it says new, so maybe there's a new angle on those words. So I'm going to predict that maybe there's something new that I'm going to learn there. That's my prediction. Now, notice as I go through that, we could also ask questions. Well, I wonder what the new vocabulary is. So we could say, I wonder what's new. I wonder what's new. We could also maybe go, I wonder how graphs, or I wonder why we're going to be looking at graphs and looking at rate of change and slope, and I wonder how it's connected to the real world. So far, it's kind of a surface glance because it's before we read, so there's not really much to clarify yet, or really summarize, except I can kind of predict our summary. Guess what this is going to be about? Rate of change and slope. How did I know that? Because the title tells me that. Okay, now we're just going to go ahead and jump into the reading. So let's read. Then you graph linear relations. Now find rate of change. Determine the slope of a line. I'm curious how they're going to have us do that. So see how I'm asking the question. The table shows the total distance a car traveled over time, intervals. The distance formula, RT equals D, or R equals D over T, relates time and distance. And then I see this table has time in hours and distance in meters, and it lists my time. Those are hours: 1, 2.5 hours, 3 hours, 4.5 hours, 5 hours, 68 meters, 170. Okay, distance. I'm curious. I need to clarify. I'm curious what this R means. What does R mean? I'm writing it here. Maybe I should write it over here on our comprehension chart. R equals question mark. What does that mean? Okay, I'm going to come back to that, I guess, later. Rate of change. Rate of change is a ratio that compares how much one quantity changes on average relative to the change in another quantity. If x is the independent variable and y is the dependent variable, then the rate of change equals change in y divided by change in x. This is sometimes referred to as, I wonder what that is. I need to figure out what that means. It says y and x. Maybe that means change. But I'm going to go ahead and mark it here to make sure I ask that question. So see how clarify and questions can also be very closely related. Okay, because we're asking ourselves, what's the question? So clarify is almost like a question that we don't have the answer to. Okay. You know what? I'm also curious. It's kind of a question / clarify. What does this ratio really mean? Clarify. Ratio really mean? So I'm going to go ahead and keep reading. Real world example, constant rate of change. Chemistry. The table shows the temperature of a solution after it has been removed from a heat source. Find the rate of change in temperature for the solution. So I'm going to go ahead and after I read that, I'm like, okay, table. So that must be this one. So I look at the table and I see time in minutes and temperature in degrees Celsius, and I notice that it goes 0, 2, 5. It looks like it's dropping. So I'm making a prediction that the time is getting longer, bigger, and notice the temperature goes from big to small. So that's kind of my prediction, is time time increases, temp decreases. So I'm going to go back and continue reading. Use the ordered pair 2, 139.4 and 5, 133.1, which I notice that that's here and here. So rate of change is the change in the y versus the change divided by change in x. And they put change in temperature divided by change in time. Wonder why that is. Well, time might be our x and temperature might be our y. And that makes sense. So change in y is temperature and change in x is time. So then they plugged in our numbers, which they also used our x and then our y. Okay? So they plugged in those numbers. And honestly, when I saw those numbers, I didn't really look at them that closely until I saw the negative. I see that negative, I'm like, uh-oh, that doesn't make sense if we're subtracting. Then I go, oh, this one's bigger. So we're subtracting a bigger one, so the negative makes sense. And then I go ahead and check their math, which is correct. The rate of change is negative 2.1. This means that the temperature is decreasing by 2.1 degrees Celsius each minute. Guided practice, recreation. The graph at the right shows the number of gallons of water in a swimming pool as it is being filled. At what rate is the pool being filled? And if I look on the next page, I notice that there's no example calculation, and this is for me to fill out. So I'm going to try it. So I need to clarify, how do I try it? So I'm going to go back to what we just read. I'm going to try to clarify this, and I'm going to look at it. Use the ordered pairs. Well, I notice, and I predicted earlier that these ordered pairs were given to us, so we must be about to use them. So let's try this. Change in y, which is this, gallons of water, over time. And I'm going to write my ordered pairs again. So what is it? 3, 108, and 7, 252. And then I'm going to plug them in. So they did 139.4 second, and this one first. So this one first, 252 minus 108 divided by 5 minus, wrong one, 7 minus 3. Okay, we did that one first. And then we calculate that. I'm going to predict that the bottom one is going to be 4. 252 minus 108, that is 144. That's my prediction, and we will check it, and we will find out that that's correct. 14 divided by 4 is 3, so 36. 36 gallons per minute. Gallons per time, which is gallons per minute. Gallons changing over time. Interesting. So let's go ahead and let's summarize. As we go through this, we could say a summary statement is the top. So we could draw a box and mark where that summary statement is. I could also say this is a summary statement. This is what a rate of change is. This is a summary statement. It pretty much tells us what rate of change is. Okay? So our summary could be, we found rate of change by calculating the change in the y over the change in x.